Let's begin with this past paper question. And I will explain more concepts through these questions. It will help you more. If x is the average of m and 9, y is the average of 2m and 15, and z is the average of 3m and 18, what is the average of x, y, and z in terms of m? So let's just apply the formulas and let's see what do we get. So if x is the average of m and 9, so that means m plus 9 sum divided by total number, we've got two terms, equals x. So this is x. Similarly, what is y? Y is the average of 2m and 15. So 2m plus 15 divided by 2 equals y. We have our x and y in terms of m. Similarly, z is the average of 3m and 18, that is 3m plus 18 divided by 2 equals z. Now we need the average of x, y, and z, that is basically x plus y plus z divided by 3. Let's do the math. Let's add all these terms up. We've got m plus 9 over 2 plus 2m plus 15 over 2 plus 3m plus 18 over 2, and this whole divided by 3. Now the denominator is common, you can simply add these terms and you will get m plus 2m is 3m, 3m plus 3m is 6m, plus we have got 9 plus 15 is 24, 24 plus 18 is 42, and this 2 will get divided with 3 and we will get 6m plus 42 over 6 is our answer. You can simplify this and you will get all of this can be simplified by 6. We will get m plus 7 over 1. Basically m plus 7 is our answer, which is option choice B. Next question. The mean score of 8 players in a basketball game was 14.5 points. If the highest individual score is removed, the mean score of the remaining 7 players becomes 12 points. What was the highest score? It's a very typical question. Let's start by applying the formula first. That is, average equals sum over total number. The examiner loves this term, please remember, and I'm pretty sure in one of the questions you will be asked to calculate the sum, like over here. So let's apply this formula. The average of 8 players is 14.5. We don't know the sum, we have to calculate this divided by 8. So the sum is, let's say this is S1, I'm calling it S1. S1 is 14.5 multiplied by 8, which is 116. Now we need to do these steps again, but with 7 players now. So let's apply this formula again. What do we get? Now we have the average is basically 12. So this is 12. We don't know the sum, over 7. So let's say this is S2. S2 is 12 into 7. That is basically 84. So now you need to understand what's happening here. Since the set of 7 scores was made by removing the highest score of the set of 8 scores, then the difference between the total of all 8 scores and the total of all 7 scores is equal to the removed score. That means S1 minus S2 should give me the highest score, the removed score. That is 116 minus 84. So the highest score was basically 32. This is our answer, which is option choice C. Let's have a look at this interesting past paper question. Number of states with 10 or more electoral votes in 2008. In 2008, there were 21 states with 10 or more electoral votes as shown in the table above. Based on the table, what was the median number of electoral votes for the 21 states? Now, this is basically called a group data, a tabulated data. It's very easy to calculate the mean or median of an ungrouped data, like we have seen the series 1, 3, 5, 7, 9. Now this is called an ungrouped data and we know that the median is 5. But I've seen that when you have group data, students get confused. You need to understand that nothing is different. The formula also remains the same. Median equals n plus 1 divided by 2. In this scenario, we are already given the frequency, that is 21. You add up all these numbers, you will get 21. This is our f, this is our x, our variable. So if I replace 21 here, what do I get? 21 plus 1 divided by 2 equals 22 over 2. That means 11th term is my median. Now let's have a look at this table. Let me write it in an ungrouped form first. So basically the table is telling us that we have 10 occurring 4 times. You can write it like this: 10, 10, 10, 10. We've got 10 4 times. Then we've got 11 occurring 4 times as well. So we have 11, 11, 11, 11. Then we have 12 occurring 1 time, which is like this. Then we have 13 occurring 1 time, like this. Then we have 15 occurring 3 times, 15, 15, 15, and so on. This is called an ungrouped form. Now you can calculate your 11th term from this, which is you've got 4 terms here, you've got 4 terms here, this is like 8th term, this is your 9th term, 10th term, this is our 11th term. So that is basically our median, which is option choice B. Now you need to understand that you don't need to do this entire exercise of ungrouping the group data. You don't need to do that. Just add up the frequencies and see which number corresponds to the 11th term. That's it. Let's have a look at this. So 4 terms are here. I haven't reached my 11th term. Let's have a look at the next frequency. I've got 4 terms here. So 4 plus 4 equals 8. So I've got 8 terms here. I haven't reached the 11th term. 8 plus 1 equals 9. I still haven't reached the 11th term. 9 plus 1 equals 10. I haven't reached the 11th term. 10 plus 3 equals 13. This is where I have my 11th term. And 3 corresponds to which value? 15. That's our median. Very simple. This is what you need to do. Please remember how to calculate the mean, median, mode of group data. That is very important. You will be asked similar questions. Okay, so now if I ask you to calculate the mean and mode of this data, how can we do that? Although it's not a question, but as I said, you should be familiar with these things. Mean equals sum over total number. That formula remains the same, nothing changes. But in this scenario, sum is summation fx. This is the sign of summation, addition, fx over summation f. Sum is this and total number is this. Now, what is summation fx? It's the same thing. It's the sum that we are talking about. So instead of writing 10 plus 10 plus 10 plus 10 plus 11 plus 11, because that is basically huge, that calculation can go like really big, because the table can be even larger than this. So how will you do that? We can't keep adding the terms. So what do? Can we write it like this? 10 times 4. We have got 11 times 4. This is easy. This is summation fx. You multiply frequency with your variable. So we have 10 into 4 plus we've got 11 into 4 plus we have got 12 times 1, which is 12, plus 13 plus 15 times 3 and so on. I'm not doing the calculation. I hope you understand what's happening. Divided by the total frequency, which is 21. This will give us our mean, our average. Lastly, what's the mode here? The mode is basically the most frequently occurring number. Let's have a look at the frequencies. So this is our highest frequency and we've got 2 numbers with these frequencies. So we have got 2 modes here. The modes are 10 and 11. These are the things that you need to remember. Next question. Number of seeds in each of 12 apples. Based on the histogram above, of the following, which is closest to the average arithmetic mean number of seeds per apple? Okay, let's have a look at the histogram. On the x-axis, we've got number of seeds. On the y-axis, we've got number of apples. So how can we calculate the mean? Mean is, the formula remains the same, that is sum over total number. So how can we calculate the sum and the total number? For that, you need to thoroughly evaluate the histogram. So the average number of seeds per apple is the total number of seeds in the 12 apples divided by the number of apples, which is 12. How do I know the number of total apples is 12? For that, you need to evaluate the axis. So on the graph, the horizontal axis is the number of seeds per apple, and the height of each bar is the number of apples with the corresponding number of seeds. For example, the first bar on the left, this one, indicates that 2 apples have 3 seeds. So this is your x and this is our frequency. Now it is simple. So this is the first thing you need to identify. Now we can apply the formula summation fx over summation f. We have already talked about this formula in the last question. So summation fx is 3 times 2 plus 4 times 0. This is important, that's why I am writing it. Plus 5 times 4. You write all the values like this. We've got 6 times 1 plus 7 times 2 plus 8 times 0 plus we have got 9 times 3. So this is our sum divided by the total frequency, which is this, the y-axis. So you add these up. You look at the heights and add up all the heights. So we have got 2, we have got 4. So 2 plus 4 is 6, then 1, 7, 7 plus 2 is 9, 9 plus 3 is 12. That's your answer. Do the calculation, do the math, you will get 73 divided by 12, which is 6.08. And the closest match is 6. The question also states which is the closest to the average number of seeds per apple. This question is like a summary of all the concepts that we have done so far. It's a very nice and interesting question. Let's have a look at this table. Items purchased by each customer. Okay. So in one column, we've got number of customers, and in the next column, we've got number of items. The table above shows the number of items 130 customers purchased. 130. So if you add these up, you should get 130. Purchased from a stationery store during one Sunday. Which of the following can be obtained from the information in the table? The average number of items, this is basically the mean. The median number of items, the mode number of items. Very interesting question. Pause the video and read the question again if you want. So, when we have to calculate the mean, what do? We basically need the sum and the total number of items. But for that, you need to identify your variable and your frequency. The frequency is already given to you, 130 customers. And in the question, you will be told what is your variable, what is your commodity, and what's the frequency. So we have to calculate the average number of items, the median number of items, the mode number of items. So this is basically our x and this is our frequency. Now do the math. So sum is summation fx over summation f. Let's put in the values and see what do we get. We have 10 into 10 plus 25 into 8 plus 45 into 5 plus 50 into what? Fewer than 5. We don't have this number. So 50 into what? I know the total frequency is 130, but I don't have this number. Hence, I cannot calculate the mean. It's straightforward. You can see from here. The next thing is the median. How do we calculate the median? Median is the middle value and the formula is n plus 1 divided by 2. How many items are there? 130. So n is 130. 130 plus 1 divided by 2 is 131 divided by 2. So basically it's the average of 65th plus 66th term. So this is the average. When you have an odd number, please remember you take the average of the middle two terms, which in this scenario is the 65th term and the 66th term. Now you know how to calculate the median of a group data. You add up the frequencies and see which number corresponds to the 65th term and the 66th term. We have got 10 numbers here. No, we haven't reached 65. 10 plus 25 is 35. We haven't reached 65. 35 plus 45. Oh, this is huge. We have 80. So that means 65th term is definitely referring to 5. 66th term is also referring to 5. 5 will continue till the 80th term. So I know the median is 5 plus 5 divided by 2. It is 5. I can definitely calculate the median. This is done. Let's now have a look at the mode. Mode is the basically most frequently occurring number. Which frequency is the highest? We can definitely clearly see this is the highest frequency that we have. And this corresponds to which number? It's not given to us. It can be fewer than 5, it can be 4, it can be 3, it can be any other number. Hence, we cannot calculate the mean, we cannot calculate the mode. We can only calculate the median. That is option choice B. The tables below give the distribution of high temperatures in degrees Fahrenheit for city A and city B over the same 21 days in March. Okay, this table is for city A and this table is for city B. Which of the following is true about the data shown for these 21 days? The standard deviation of temperatures in city A is larger. Okay, so basically we have to find out the standard deviation and compare the standard deviation of both the cities. But before we begin, we need to understand the definition of standard deviation once again. So if you recall, the standard deviation is a measure of how far the data set values are from the mean. How scattered the data is. Just remember this term, how scattered the data is. Now let's evaluate both the tables. In the data set for city A, the large majority of the data are in the 3 of the 5 possible values. Now you see, these 3 are basically closest to the mean as well. So that means the data is packed close together. The standard deviation won't be that high. That is something that you should be able to guess from this data. Whereas in the data set for city B, the data are more spread out. We've got 6 values at the maximum value, which is 80, 6 values at 76, which is the minimum value. And even in between, the data is scattered. So you can definitely say that the standard deviation for city B should be larger. Now, in case you are unable to find out from this data, you can calculate the mean as well. It's completely fine. So let's calculate the mean. For A is basically sum over total number. I have done the calculation for you. So if you multiply these, you will get basically it's summation fx over summation f. The summation of the values will be 1655 divided by the total frequency, which is already given to us. It's 21. You will get 78.8. The mean for city A is 78.8, whereas the mean for city B is, again, the same scenario, sum over total number. If you do the math, you will get 1637 divided by 21. Frequency remains the same. You get almost 78. Now, if you evaluate city A, most of the values are close to the mean, 78.8. Whereas if you look at city B, we have got only 2 values are at 78. And then rest of the values are scattered. That means standard deviation for B is greater than for A. Sorry, it's A. Now let's have a look at the option choices. The standard deviation of temperatures in city A is larger. No, it's the opposite. The standard deviation of temperatures in city B is larger. Yes, definitely. You don't even need to look at the other option choices. Next question. Ages of 20 students enrolled in a college class. We have the age, we have the frequency. This is frequency, this is our X. The table above shows the distribution of ages of the 20 students enrolled in a college class. Which of the following gives the correct order of the mean, median, and mode of the ages? Okay, interesting. We need to calculate all these three. So the frequency is 20. Let's start with the mean first. Mean is sum over total number, which in a group data is summation fx over summation f. Let's do the math. We have 18 into 6 plus 19 into 5 plus 20 into 4, and don't worry, you will get these questions in the calculator section. This is section 4, so don't worry about that. Plus 21 into 2 plus we have got 22, sorry, this is plus, no, I need to erase it, it might be confusing, plus 22 into 1 plus 23 into 1 plus 30 into 1. This is frustrating writing all these numbers but I hope you understand. Okay, divided by the total frequency, that is 20. You do the math and the mean will come out to be 20. Okay, this is our mean. Let's now calculate the median. Median is the middle value. You know how to calculate the middle value of a group data. The formula remains the same, n plus 1 divided by 2. We've got 20 values, 20 plus 1 divided by 2. So whenever you have an even number, the median will be the average of the two middle terms. So we've got 21 divided by 2, which is basically the average of 10th plus 11th term. The average of 10th plus 11th term, which comes out to be, at the frequencies, we've got 6 plus 5, 11. So we've got the 10th term here and the 11th term here as well. So the median should be 19 plus 19 divided by 2, which is 19. This is our median. Lastly, we have got the mode, which is basically the most frequently occurring number. The highest frequency is this, which corresponds to 18. Now we have got all these terms. So the mode is basically the smallest. Let me write it here. We have the mode, which is the smallest. Then we have this number, which is the median. And lastly, we have the mean, which is 20. This is our pattern. This is our answer, which is option choice. Mode is less than median is less than mean. Yes, definitely A is our option choice. Let's have a look at the other option choices as well. Mode is less than, no, this is wrong. Median, no, all are completely wrong. Definitely A is our answer choice. Next question, another very good past paper question. The 22 students in a health class conducted an experiment in which they each recorded their pulse rates in beats per minute before and after completing a light exercise routine. The dot plots below display the results. This is beats per minute before exercise and this is beats per minute after exercise. Let S1 and R1 be the standard deviation and range respectively of the data before exercise, and let S2 and R2 be the standard deviation and range respectively of the data after exercise. Which of the following is true? So we basically have to calculate the range and standard deviation of each data set and then calculate the values. Let's begin with the range because it's easier to calculate. Let's say range 1 is basically this and range 2 is this. Range 1 is basically, what's the formula? We have the largest value minus the smallest value. This is easy to calculate. Let's have a look at the dot plot. The largest value is this and the smallest value is this. Let's plug in the values. 88 minus 56 equals 32. Now let's have a look at range for the second data set, that is R2. Again, largest minus smallest value. This is the largest value and this is the smallest value. So we have 112 minus 80. That also gives us 32. So that means both the ranges are equal. R1 equals R2. Now you should immediately look at the option choices because you should be able to eliminate couple of option choices with this scenario in mind. So let's have a look at the option choices. In option choice A, we have R1 equals R2. Let's keep this. In option choice B, R1 is less than R2. You should definitely eliminate this. In option choice C, we have R1 greater than R2. Eliminate this as well. In option choice D, we have R1 equals R2. Let's keep this option choice as well. Now we need to look at the standard deviation. Now this is important. You need to understand that the two data sets have different standard deviations. How do we know that? Both dot plots show distributions that have a mean near the center value of the dot plot. This is something that you should be able to identify. I don't know the exact value of the mean, but I know it should be somewhere here. It should be somewhere here. The first dot plot shows most values clustered near the mean. Look at this. The values are packed close together. Whereas the second plot shows most values farther from the mean. It is scattered. The data is scattered throughout. Hence, you can easily say that S1 is basically less than S2. Standard deviation for the second dot plot is higher. That means we are left with option choice D and not A. S1 is not equal to S2. The standard deviations are different.